what's something you noticed about this pattern? Everybody notice something? Something you noticed? Renee? You're looking at multiplying? 2, multiplying by 3, multiplying by 4, multiplying by 5. So we see a pattern. Whatever that is. It's just writing the equation might be a little bit tricky. I wanted to show you this one because I know sometimes you're going to get patterns that look like this. And every time you see patterns that look like this, they're all related to this one thing I'm about to show you. Before I show that to you, will you factor 2 for me? Do you know what I mean? What multiplies together gives you 2? What's 6 factored? Prime, like all the way down. Well, not prime, but just 6 is 2 times 3, right? 24 is 6, which is 3 times 2 times 4, times 4. $120 is just take the previous one and multiply by 5. $720 is take the previous one, multiply by 6. So I'm taking the previous factors and just multiply by one more number. So what's 50/40?
What?
It is. Okay. So, has anybody seen numbers that do this?
Yeah. I just don't know how to like start.
It's written with an exclamation point. It's called a factorial. So, 50/40 would be 7 factorial, which means 7 times 6 times 5 times 4 times 3 times 2 times 1. You just take whatever number has the factorial, which is the exclamation point, we call it factorial. Take whatever number that is, and you multiply by each number minus 1 after it. So like 7 minus 1 is 6. 6 minus 1 is 5. 4 minus 1 is, 5 minus 1 is 4. Let's multiply by the number lower than it each time. So if I do something like 10 factorial, what would we write? Right? What if I wrote n factorial? N times n minus 1 times n minus 2 times n minus 3, and then so on until we get down to 1. However many that is. You're just taking 1 away each time. So the equation that we have for this one up here is a sub n equals n factorial. Let's see one point there. Where if 1 was n, then you just get 1. If 2 was n, you do 2 times 1. If 3 was n, if 3 was n, you do 3 times 2 times 1, which gives you 6. So if you see any equations that you're multiplying by like the next consecutive number, that's going to mean there's a factorial somewhere in your formula. Okay. The rest of those we're going to go over together in a moment, but before we do that, let's talk about a little bit of vocabulary and how we get terms before we go over how you find the formula for the terms. So as I'm passing this out, I want to let you know there isn't one formula that works for every single equation. So this is why some people get anxiety over this, because there isn't one formula. Now there is a formula that works for certain ones, and there's another formula that works for other kinds, But there isn't one formula that works for everyone. So you're going to have to do some thinking to figure a lot of this out. You might have to make a couple mistakes and then figure out the right way after that. Me too. It happens. So here's some vocabulary. Today we're starting sequences and series with just chapter 9. We've already done 7 and 8. So we're going to 9.
When did you do that, like first quarter?
Yeah, it was 7 was systems, linear programming, and 8 was matrix. Yeah, because we flipped it. We did it earlier. Okay. So the first vocabulary word is sequence, and a sequence is just the set of well, the domain is 1, 2, 3, 4, 5. The domain, like the input, is which term it is, and then the output would be you just do some sort of function to that, but you just like list them with a comma. That's a sequence. Series is something different. Not doing series till whenever we see each other next. Finite sequence would be a sequence that stops. Infinite sequence would be a sequence that goes on forever. And each member in the sequence is called a term. So if I talk about this term here, I'm talking about the first term. And when we talk about that term, we're going to call it A sub 1. That's subscript. That means the first term. A sub 2 means the second term. So that sub number is not an operation, but it's just telling you which one. So A sub 4 is the fourth term. What's A sub n? The nth term. It is not the last term. It is the nth term. Okay, then going, excuse me, right back up to this part right here. We know which term it is because the first term is always when n is 1. The first term, n is 1. The second term, n is 2. It does not start with other numbers when we're given a pattern. It doesn't start with other numbers. We're going to make it 1 every time. Okay, for now, please. So here we're going to find the first 5 terms of this sequence. So this tells you A sub n. We're going to find the first 5 terms. We're going to find A sub 1, A sub 2, A sub 3, A sub 4, and A sub 5. To do that, you have to plug in 1, plug in 2, plug in 3, plug in 4, plug in 5. So we'll do 5 times 1 minus 3. 5 times 2 minus 3. 5 times 3 minus 3. 5 times 4 minus 3. 5 times 5 minus 3. I don't understand what you mean by search numbers. What did I plug in? Because the n is which term it is. And we want to find the first 5 terms. So we want to find the first term, second term, third term. So we're putting n as 1, and then n is 2. Okay? The n is which term it is. Except my hand. Now, to help you when you actually have the terms listed and you're going to go find the pattern, which they've already told us the pattern here, but to help you in the future, what do you notice about 2 to 5, or 2 to 7, 7 to 12, 12 to 17, what do you notice about each? They're adding 5 each time. It's going up by 5 each time. Now, in the equation, there is a 5, and that is not a coincidence. It's 5 multiplied by the n. There's also a minus 3 in there. But like the 5 part is not a coincidence. If you're going up by the same amount, that's going to be multiplied by the n. You just have to figure out the rest of it over here. Okay, here's the next one. Find the first 5 terms of the sequence. So we're going to plug in 1, then we're going to plug in 2, we're going to plug in 3, plug in 4, plug in 5. So do -1 to the 1, and then 1 squared. -1 to the 2, and then 2 squared. -1 to the 3, 3. There are multiple places where I could plug in the n. And then I'm just going to use my order of operations and find each answer. And then when I plugged all this stuff in and I found each answer, this reminds me somewhat of the second example on that worksheet last night that a lot of you had trouble with. The second example, why was that one tricky? You have that worksheet up still? Because we're trying to need it. Why is the second one tricky? Because we have negative, positive, negative, positive, negative, positive. But so does this one. What's making it go negative, positive, negative, positive? What's making that happen? The -1 to an exponent. Because if I have -1 to an even amount, it's going to be positive. If I have -1 to an odd, it's going to be negative. So if you see that you have negative, positive, negative, positive, it doesn't have to be -1. It could be negative. It could be like -10 to some power. If I do -10 to the even power, it's going to be positive. So it doesn't have to be -1. It could be negative anything. But if you have a negative number with an exponent, that's going to help you figure out the negative positive thing. And you just have to figure out how to get the rest of the numbers with it. Okay, the next one says n factorial divided by 2n, but it does not say find the first 5 terms. What does it say? Find the 5th term. You only have to do that one time. You just have to do a sub 5. So that means if we're doing the 5th term, we're going to plug in 5. So you do 5 factorial over 2 times 5. What do we need calculators for? I'm just getting ready. You think you need it. You don't need it. It's super easy. When you have factorials, they're kind of they have a hidden secret to them. If you expand them out, it becomes easier. So on top, I'm going to expand 5 multiplied by what? 4 times 3 times 2 times 1. On the bottom, I have 2 times 5. You notice this is all multiplication. There's no addition. You can cancel. So I'm going to cancel the 5s and the 2s. What am I actually multiplying here? All right, 4 times 3. Get those calculators out. It was like the 2 of them were all like, oh, I'm going to need this. So, as soon as you're ready to go on to the next page, you'll see we've got some more factorial practice. And I'll show you how they're easier. Okay, so here we're going to simplify. Now, this is not doing the a sub anything. This is just practicing with factorials, which we're going to apply factorials in a few days. So today we're just learning about factorials. We will apply them in a few days. So here I'm doing 3 factorial divided by 7 factorial. First thing I want you to do is think about expanding them out. And it's all multiplication. So what's going to cancel? So what do I cancel 3, 2, 1 out of the numerator, everything's gone except there is something still there, which on top. 1. In the denominator, you might use a calculator, but I don't. You might need it at this point. 7 times 6 is 42, and 5 times 4 is 20. 42 times 20? 42 times 2, with a 0 at the end. Did it before you tapped it in. It's okay if you need it on some of those. All right, how about the next one?
Almost 100. Yeah.
Huh?
Everything else cancels.
Because everything else is going to cancel. Okay, so I don't really need to expand the whole thing. I'm going to start expanding. 100 multiplied by 99 multiplied by 98 all the way down is 98 factorial. On the bottom, I have 98 factorial. So I'm expanding the 100 until I get to 98 and everything down. I don't need to expand that any further because that's all going to cancel. So what's 99 times 100 without a calculator? 9900, right? 9900. How do I know which one I should expand? Can you generalize which one I should expand? The bigger one. Expand the bigger value. That's how I know which one to expand. I'm going to take the bigger one and make it smaller so I can cancel with whatever's left over. Why do I say that? Because when we look at the next one, there's no numbers. So we need to expand the bigger one. Which one's going to be bigger? N minus 2 or N? You're going to expand the bigger one. So on top, N minus 2 factorial. On the bottom, I'm going to start with N. Then I'm going to multiply by 1 less. N minus 1. Then I'm going to multiply by 1 less than that one. N minus 2. Oh, and then it matches, so I'll hit factorial there. Which cancels, and we get 1 over N times N minus 1. You don't have to. If you want to do extra work. What happens if I have something like an answer that's like what if that's my denominator when I'm done? You're gonna want to multiply all that? There's no reason to. So I would just leave it. Okay, how about this one? Which one's the bigger value? The top. So we will expand the top. We'll have 5n plus 1, and then we multiply by 1 less than that. What's 1 less than 5n plus 1? 5n. Oh, and then I can cancel. So we get 5n plus 1 as our answer. Okay, let's look at our sheet that you were supposed to do for your assignment last night. So let's look at that. And then after we go through that sheet, we have 2 more examples to do. Question? Question? Anyone ask me a question? They can hear too. Yeah. I'm not here. All right. Where's mine? You guys, all of you that started it, did okay on the first one, yeah? So you looked at it and you were like, oh, that's just like adding 2 each time. in that voice you said. Okay. And then a lot of you wrote like n plus 2, but that's not right. And then I came over and I said n plus 2. The n, this helps you, the n is the term number. So if it helps you to kind of like do this first, that, from my opinion, from me seeing students, working with students, writing the 1, 2, 3, 4, 5 above it seems to help more. So then we say, what do you do to 1 to make it into 2? What do you do to 2 to make it into 4? And what do you do to 3 to make it into 6? And you might be able to answer that question, but sometimes it's a little harder. So I have helpful tricks and tips. If you find the differences like this, which are called finite differences, if you have the first finite difference is constant. So if you do this once and it's constant, that tells you that your equation is linear. And linear is always like, what equals nx plus b? Where like the variable's to 1 power and we might add something afterwards. So it tells you that the n is to the first power. There's something else that it tells you when it's one finite difference. This number is multiplied by the n. It tells you that. So I know my equation to start is going to be that number, that plus 2, multiplied by n, and it's to the first power. Now all I have to do is start plugging in 1, 2, 3, and seeing if it equals those numbers, or if I have to maybe add something or subtract something after that. So I do, like 2 times 1, does that equal 2? 2 times the second term, does that equal 4? 2 times 3, does that equal 6? 2 times 5, does that equal 10? I'm like checking them. That works every time, right? So then I know my equation is going to be, we write a sub n equals 2n. That's how you're going to write the form of the equation. You write a sub n equals, and then the formula 2n. These are going to be basic examples, and then they're going to get trickier after today. So you got to understand these tricks. These tricks. This trick works for this one. It might not work for that one. You have to understand all of them. So this one, what do you notice about this one? The negative and positive. We know there's alternating negative and positive. There's something also I noticed is the n, the term number, is the same as the a sub n number. It's just alternating negative and positive. So that means we're multiplying by some negative number to an exponent. And since these numbers are exactly the same, I'm probably just multiplying by negative 1. If I plug in my first term here, I plug in my first term, 1, does that give me negative 1? If I plug in 2, does that give me 2? Negative 1 squared only gives me positive 1. If I plug in negative 1 to the third, does that give me negative 3? No, it just gives me negative. So I still need to get the 1, the 2, the 3. So what can I do to negative 1 to make it into negative 1? What can I do to positive 1, negative 1 squared, to make it into 2? Plus n? Multiply by n. If I multiply by that n value, after I get the negative number, then multiply by 3, I'm going to get negative 3. So there's where you're just kind of playing around and asking what I can do to make it into that number. So this is the formula here. And I kind of did that piece by piece. I figured out the negative part first, then I figured out the 1, 2, 3, 4, 5. All right, this next one, you may have looked at it and been able to recognize pattern. They're not all that easy, so I'm going to show you how I could do it if it was a little bit harder. I'm going to pretend this is a pattern I can't recognize. And I'm going to start seeing if there is differences that have a pattern. So I'm going to say 1 plus 7 and 8 plus 19. I already did it on my paper. And then 27 plus 37 and 64 plus 61. I'm not quite sure if that's a pattern. I'm going to do it again. I'm going to do a second finite difference. And 7 plus 12 is 19. 19 plus 18 is 37. And 37 plus 24 is 61. And these aren't constant, but I'm starting to see a pattern. What if I do it again? 12 plus 6 is 18, and 18 plus 6 is 24. So what I have here is I have third finite difference is constant. So if you were not able to recognize that formula right away, try finite differences. And if you get to the third finite difference being constant, that tells you that this is going to be a cubic equation. That's what it tells you. That tells you we're going to have n to the third somewhere in our formula. And then we just need to figure out if it's n to the third, or maybe it's n to the third plus 5, or maybe it's n to the third times 2. We're going to figure out what we do to the n to the third. But it's going to be an n to the third somewhere. So now I use my n's, and I do 1 to the third. Is that 1? 2 to the third. Is that 8? 3 to the third. Is that 27? 5 to the third. Is that 125? So I don't have to change n to the third at all. I have my equation. A7 equals n to the third. But they're not all as easy. So I took all that time to go through that. You guys see finite differences last year? Should have.
I missed a board.
Yeah, I don't know.
So didn't do this at all.
Did you have? Miss Lee did it. Yeah. Miss Griswold did it. Do you remember? Yeah. All right. Next one. So for this one, you might start out by doing finite differences. Okay? It's not going to work the first time. So then you go and you do a second one. It's not going to work the second time. You do a third one. It's not going to work. And then you're like, you know what? This pattern is not even getting better. So it's not plus something every time. But you might look at it and see it's not something that we're adding each time, but instead we're doing what each time? We're multiplying each time. So if you're multiplying each time, the finite difference thing will not work. If you're multiplying each time, it's something different. Multiplying by 2. Multiplying by 2. Multiplying by 2. 2. If you are multiplying by the same number each time, it's exponential. An exponential means this is the base, and we have n as the exponent, maybe. So that number you're multiplying by becomes the base. So I'm going to try this out, put in my 1, 2, my n values. And I'm going to do 2 to the n. I'm going to try that out. So if I do 2 to the first, it is supposed to equal 1. It does not equal 1. If I do 2 to the second, it's supposed to equal 2, but it does not. If I do 2 to the third, it's supposed to equal 4, but it does not. What do these equal? 2, 4, 8. 2 to the 4th is supposed to equal 8, but it equals 4 and, no, just kidding, 16 instead. What'd you say? Divide by 2. Will that work each time? Will that work each time? Yes? I'm going to get there. Totally right. You're totally right. So you said divide by 2. I'm going to write it, but I'm going to simplify it after that. And then it's going to be what Caleb said. I don't know if you understood what he said. So if I have 2 to the n, and then I divide by 2, this is not as simplified as can be. Because what we're doing is we're dividing like bases. That would be like having, I'm just going to go off to the side here. That would be like having x to the 5th over x to the 3rd, and would that be simplified? No, what do you do to the exponents when you're dividing like bases? Okay, so that's what I'm going to do. What's my exponent on this one down here? So I'm going to have 2 to the n minus 1. I'm going to show you how that will work. So if I had 2 to the 1 minus 1, that's the same thing as 2 to the 0. And anything to 0 corresponds. If I had 2 to the 2 minus 1, that would be 2 to the 1st, which is 2. If I had 2 to the 3 minus 1, that would be 2 squared, which is 1. So it works out. So our final one is a sub n equals 2 to the n minus 1. So this is good, but it's just not simplified all the way. Okay? All right, are we multiplying by the same thing each time here? Nope, thanks for answering. Are we adding the same thing each time here? No, but when I start writing what I'm adding, I kind of feel like there's a pattern. So if I do a second finite difference, it's now constant. So if the second finite difference is constant, what's that mean? It means squared, n squared, somewhere in the equation. And we can check it. If I do 1 squared, does that equal 1? 2 squared, does it equal 4? 5 squared, does it equal 25? Yes, so we just have a sub n equals n. Constant difference? We just did those numbers right above it. That was our first finite difference. Okay, so this, since there's one finite difference, that tells me what kind of equation it is. What kind? Linear. So I know it's going to be n, but since I'm adding 2 each time, it's going to be 2n. So if I plug in my n, if I plug in 1, do I get 1? If I plug in 2, do I get 3? If I plug in 4, do I get 7? So I have to do to all these numbers to make it into these. Subtract 1 each time. Right? So 2n minus 1 is our linear a sub n equation. You can do these all on your own because you can explain the rest if you'd like.
I can't explain the next one.
Well,
I
then
can
I would get
explain
off
the last.
Snapchat. I'd get off Snapchat. All right, next one. Fractions can be much easier if you think about them as just being 2 separate problems. Look at all the numerators, and look at all the denominators separately. Look at all the numerators and all the denominators separately. 3, 9, 81, 243. I didn't write one on purpose. 2, 4, 8, 10. I didn't write that one on purpose because it didn't fit the rest of the pattern. Can you see a pattern on top and the bottom separately? Just separately, bottom, top, except for that one is different. What should be missing? What should be missing right here? 27. Because what are you doing each time? Instead 3. And then what should be here? Because what are we doing each time? Okay, well, 9 over 2 is 27 over 6. It is. It's just reduced. If I multiply 9 and 2 by 3 over 3, it becomes 27 over 6. It's just reduced. Because we always reduce fractions. So sometimes when you got fractions, you want to look at the top and bottom separately, and then also some of them might be reduced. So try to find the ones that have the pattern, and then unreduce the ones that don't. So since on top I'm multiplying by 3 each time, that tells me that 3 is the base of an exponent. On the bottom, since I'm adding 2 each time, that tells me I'm multiplying 2 by the number, the term number. And then we can plug in 1 on top and bottom, and it does equal 3/2. We can plug in 2 on top and bottom, it does equal 9/4. You can try all of them, and they will all work. So this is our formula. Going a little fast. I'm going to skip the last one. This last one's linear and it's easy. We have one last little section. It's this section right here. This is really easy. When you see recursive formulas, you are repeating a procedure on a previous term. So a recursive formula, which is what I've given you here, is not something where I can find just the 10th term. In order to find the 10th term, I would need to know the 9th term. To find the 9th term, I need to know the 8th term. What term was I given? The first term. So in order to find the 10th term, I'd have to find term 1, 2, 3, 4, 5, 6, 7, 8. Not the best formula ever. But what we can do is we can find terms and then we can write the nth term from the pattern that we find. So what we're going to do is we're going to find the first 5 and then we're going to write the nth term from that. So this says our first term is 15. Over here, this says, right here says a sub k plus 1, like the k plus 1 is all in the bottom. It's kind of hard to tell. And then this is a sub k. This means any term, or it means the previous term. And this right here means the next term. So what am I doing to any term to get the next term? What am I doing to any term to get the next term? Adding 3. So to find my next term, a sub 2, I take 15 plus 3. So the second term is 18. The third term, you take 18 plus 3, 21. The fourth term, 21 plus 3, 22. The fifth term, 24 plus 3, 27. So we're just taking the previous term and doing whatever they want us to do. So I have 5 terms. Now this next question I ask should be really easy. What am I doing to each term here? I'm adding 3 because that's what they told me to do. Uh-oh. Exactly. I wonder if my computer is filled up. Might be. So I'm adding 3 each time. So that means my formula is going to be something like 3n. Does that give me each of these numbers? If I do 3 times n, do I get 15? How do I get 15? It's going to be linear, so it's going to be 3n plus something. 12. So you can check that with any of them. I'll check with the fourth one. If I take 3 times 4, and I add 12, do I get 24? Yeah. So that's the equation for that one. Okay, look at the last one. Let's see if I go over my limit. on space. For this one, what are we doing to the next term? Multiplying by -2. Go ahead and find the first 5 terms. I'm going to see if my space is used up. That's why it's acting weird. Should clear it. Okay, so what do we got? 14 times -2. That's -28. Let me apologize for my handwriting that I can't even read. So you take the previous term and you multiply by -2. You take the previous term, you multiply by -2. You take the previous term and you multiply by -2. So we have to write our a sub n. So I like to list my numbers out so I can use them. And you should be able to answer my question now. What are we doing each time? You just did it to find all these numbers. We're multiplying by -2. So if you're multiplying by the same thing, that becomes a base to an exponent. And we have to figure out if that gives us the term or if we have to do something else to it. So if I do -2 to the first power, do I get 14? If I do -2 to the second power, which is 4, do I get -28? If I do -2 to the third, which is 8, do I get 56? Oops, that's -8. Do I get 56? What can I do to these numbers? It's the same thing every time. Yeah. So -2 times 7 is positive 14.
Oh, -7.
-7, yeah. So when you get an idea like that, which is a really good idea, check it on a couple of them, and then you'll realize, oh no, it's -7. Okay. So I'm going to put up the assignment. I will post that video, and you will do your assignment tonight. And you will not jinx it for everybody else. Because you know, if you do your homework, what happens? It increases the chances for a snow day if you do your homework. It's a proven fact. Yes. Let me pause when we stop the video. And